Okay, I've got a trig equation. It's going to be expressed like this, and it's got cos squared, cos, that's a disguised quadratic. So I've got to get rid of all the tans and the sines. So knowing what I've got to do can often help. So the first part, first off, I can times by tan x on both sides. So it can be 2 sine x. And because I don't want tan x, I'm actually going to make it sine x over cos x. So sine x over cos x, that's my tan x, equals, and that'll just give me 4 cos x minus 1 on that side. And now I'm going to sine x times sine x will give me sine squared x, and I'll be able to change that for cos squared x. And I'm going to times both sides by cos x as well. So that will give me 2 sine squared x equals 4 cos squared x minus cos x. And I know that sine squared is 1 minus cos squared. So 2 lots of 1 minus cos squared x equals 4 cos squared x minus cos x. And if I multiply this out, I should be able to see pretty much where I'm going. If I can't, then I can just have a quick look, just to check that I'm okay. I ain't got the x's on here, so I can get everything onto the right hand side. So that would be add 2 cos squared x, that'll give me 6 cos squared x minus that cos x minus 2, and that equals 0. And that's the first part. Part 2, hence, okay, so I've now got this, and this expression, just check, it's exactly the same. 2 sine x is exactly the same. Sometimes they may double something or do something like that, but here it's exactly the same as I've got here. So all I have to do is solve this. So I will write it out to start off with again, and I'm going to, I like it always equaling 0. So I think, does it factorize? Well, if it does, I'm going to go, you could put let's whatever, but I'm quite happy to go like so. Alright, to get 2, it's got to be 1 and 2, which is minus 2, so 1's plus and 1's minus. So I'm going to put those in to start off with. 2 and 1. 1's plus and 1's minus. To get the 6 cos squared x, I've either got to have 1 and 6 or 2 and 3. And these 1 and 6 are going to hit these ones here, so if it's 1 and 6, it's either going to be 1 and 12 or 6 and 2, so it won't be that. So it's going to be 2 and 3. I want to get minus cos, so 2 and 3. If I put the 2 here, that 2 is going to times by that 2 to give me 4, and that 3 will times by the 1 to give me 3. That's good. I want it to be minus, so I want the 4 to be negative, so that's going to have to be minus, and that's going to have to be plus. Just check, 6 cos squared x minus 4 cos x plus 3 cos x is good, minus 2. There we are. So now, something times something equals 0. So either the first one equals 0, or the second one equals 0. So take away 1 from the rest, so that will give me cos x equals negative a half, or cos x equals, add 2 to 2/3. And so therefore x will equal cos to the minus 1 of negative a half, or x will equal cos to the minus 1 of 2/3. And that will say that's x equals 120 degrees. But when you've got cos, it's always 120 degrees or minus 120 degrees. And it comes from the unit circle. So like that. If cos to be minus a half, that's my cos axis, minus a half there, that's the angle, 120, or to get to there, it could be that angle, which is obviously minus 120, and each of those repeats every 360 degrees, or 360 n degrees, plus 360 n degrees, or x equals cos to the minus 1 of 2/3, it's 48.1896, don't forget, or minus 48.1896. And each of those repeats every 360 n degrees. And now I can work out what it is, because I've got to give all the angles between 0 and 360. So it could be, the first one it could be is here, 48. So that'd be 48.2 degrees. The next one, that's negative, it will be this one here, 120 degrees. Next one is not there, because that's very nearly 360. It's going to be here, isn't it? Minus 120 plus 360. That'd be 240 degrees. I suppose it should be that or. And the last one is if n here is 1, so it's minus 48 plus 360. That is 311.8 degrees. Sometimes it might be given as 312 degrees because everything is given to 3 significant figures. But I think if you give an angle to 1 decimal place here, it probably should be to 1 decimal place here. Anyhow, that's question 5 done.